Welcome. So, I decided to do some full exam paper walkthroughs. I'm going to start with an introductory section, which is actually nothing to do with the exam paper itself. Exam paper I'm going to start with is paper 1 from 2016. That's the most logical thing. It's the first paper that got done on the new spec. But before we even start to look at it, and before I explain how I'm going to approach it, let's talk a little bit about this. In an exam, you're always going to have one of these, okay? It might be worth drilling yourself or training yourself to put information onto it as a matter of course. You won't be able to do it until the exam starts, but if you do it and you've trained yourself to do it in a very specific way, then what you've done is you've basically provided yourself with a legal cheat sheet. Yes, it doesn't tell you the answers to specific questions, but it really does give you a lot of information. So let me just talk to you about what I mean, okay? First thing I'd probably do is put a plus there. Oh, hold on. There we go. A plus there, a plus there, a plus there, and then leave that for now. And then we turn this into -3, this into -2, this into -1. What I'm doing here is putting the charges of some simple main group element ions above the group numbers or next to the group numbers in the periodic table. So this is really basic chemistry knowledge. It's GCSE standard really, but it's very easy to forget it now and again. It does cause the odd problem, it doesn't necessarily reflect things like variable oxidation states, but it's a good starting point. Something else that's worth doing, again a fundamental sort of thing, is to give an approximate diagonal line. It's actually a bit more of a grey area, okay, so you might see it done in several different ways. And what we're doing here is roughly separating one side of the periodic table, the left hand side, which is the majority of elements which are metallic, right? The right hand side, which is a smaller proportion of the elements which are non-metallic, non-metals. And the reason that we're doing that is to remind ourselves about some basics to do with how these elements bond with one another. So pure metals would have metallic bonding, combination of metal and non-metal is ionic, combination of non-metal and non-metal is covalent. It's important, again, it's sort of GCSE standard stuff, but it's easily overlooked, okay? Other things that we should do, definitely A-level sort of level stuff, right? S, P, D, right? And you can put F down here as well, if you want, okay? What we're doing there is assigning the blocks to the periodic table. The S block is group 1 and 2. The P block is all this stuff on the right hand side, and then the D block is what we would have called the transition metals at GCSE, this section in the middle. Again, if you're an experienced A-level student, you should know all this, and the reason it's relevant is because it will remind you about how electron configurations work a little bit. Speaking of those, I always advise my students to try and remember to put a little asterisk above chromium and above copper. I'm not going to go into why, but they're special in terms of their electron configuration, and the easiest way of you remembering that is just to mark them out, right? Even if you don't remember the specifics whilst you're doing this with the periodic table, when you are asked, if you are asked, to justify or give the electron configuration of chromium or copper, you will check the periodic table, at least you definitely should, and you'll see, I've put a star next to that, and that might remind you of something. Next part might be overkill, but it's probably worth talking about. Again, you could drill yourself to do this so that you do it in a very systematic way and you are quick at it. You could get 5 blank periodic tables and do it 1 week, do it another week, do it another week, do it another week, and try and do it from memory. But one more thing you could do is put some of the more common polyatomic ions formulae down on the sheet. So hydroxide, carbonate, sulfate, ammonium, nitrate. You could have phosphate if you want, although that tends not to come up too much. Well, occasionally, I suppose, in the full A-level paper 1. There's probably some others we could stick on here as well, but again, you don't want to go too crazy with the amount of stuff you have to do. I guess the only other things that I might say are a hydrogen ion and a hydride ion. They're both things that you might be asked a little bit about. So then, what I'm trying to say is, you do that before you even look at the paper, right? And if you train yourself to do that really reasonably quickly, then as the first thing before you even answer any questions, you've got a good chance of then looking back at the periodic table and having some serious help from all of this information. Yes, it's quite a lot to remember, but there's a lot to remember anyway, so you might as well try and give yourself as much help as possible by systematically kind of, writing them out. You could even learn the ions in a particular order and then just write them from left to right across the top. Anyway, let's get to it. So I'm going to do the video in sections and then probably stitch it together and obviously upload the full paper so that you can have a go at it. What I'm not going to do is just walk you through the mark scheme, because there's not much point in that. Mark scheme is publicly available, you can find it yourself. It would not be a good use of anybody's time for me to just read that out. The purpose of the video really is for you to kind of listen and try and appreciate thought process as much as anything else. It's not really to do with the fact that I'm just going to give you the answers. And there might be some questions where I don't even bother. Things that are just pure knowledge. I might just say, this is knowledge. You can find this in a textbook. Move on. Okay? So then, let's have a look. We start with some kind of, overview, atomic structure, electron configuration type stuff. Okay? First thing to point out in terms of technique. We see that word. Full. That means no noble gas shorthand. And actually, oh, look at that. There's chromium. Okay? Now, we'll do them one at a time, right? You'd have to cross-reference with the periodic table. There are a number of different ways you can do this, right? But I'm going to go with my preferred method. I can see where aluminium is, right? I can see that it is in the P block, okay? I'm not going to annotate everything because the periodic table will get a bit messy, but you can see it's a group 3 element in the P block, okay? It's in the P block and it's in period 3, and it is 3 elements across. In fact, I will annotate just to make it really clear. Okay, so if we just wang down the thickness on that, stick it on green. So here's aluminium, just to be clear, right? It's in the P block, it's in group 3 like we just said. The fact that it is 3 elements along in the P block, right, means that it must have 3 elements along in period 3 means it must have 3 electrons. 2 of them are in the S sublevel, 1 of them's in the P sublevel. So what I'm trying to say is there's a lot of ways you can check very easily how the electron configuration should be built up. Okay, so we've just said that aluminium is going to have an electron configuration that ends 3p, and then from that point onwards, after you figured out that it's 3p1 because it was 1 element into the P block, everything else is full, and so you just kind of fill out the remaining electron configuration. So 1s2, 2s2, 2p6, 3s2, 3p1. I'm not going to tell you how you're supposed to know that because that's not the purpose of this video. That's, go and look at something on electron configuration at A level if you want to learn how you're supposed to know that. Or, look at your notes from when you were taught it. It's not kind of the idea behind this, but that's how we derive it. Okay? Chromium 3+, because this is an ion, probably the best logical way to do it is to actually give the electron configuration of the corresponding atom and then remove 3 electrons. Okay? So, chromium, right, is down here, and it's one of the special ones. Now, actually, as it happens, because of the nature of this chromium ion, the fact that it's special isn't going to come up, but I'm going to mention it anyway because we're going to look at the atomic electron configuration. So it's a D block element, right? And it's 4 elements into the D block, but there's actually an issue with that and the way that we write its electron configuration. Okay? So, chromium atom, 1s2, 2s2, 2p6, 3s2, 3p6. So far, what we've basically done is change the colour, right? Trace the line 1s, 2s, 2p, 3s, 3p. All of that I've just marked out in red, that's represented by all of these elements. That's all, everything that's filled up. And then we get to period 4 here, and things do start to get a little bit complicated. But right, let's just check that we're happy with it. So the thing that is special about chromium is, instead of adopting this electron configuration, which is incorrect, it has this electron configuration. Same number of electrons, but you get this partially filled S sublevel and a half filled 3D sublevel. Again, I'm not going to explain why you're supposed to know that. Actually, A-level chemistry doesn't explain it anyway, but it's not something that I'm going to dwell on, okay? The important thing is the process. We now need to take away 3 electrons, okay? So chromium's special because it's got 1 electron in the 4s rather than 2, which is what you'd expect. But it's also special because it's a d-block element, and in all d-block elements, the first electrons to be lost are the 4s electrons. So we're going to get rid of all of that, right? That now represents chromium plus. The next thing to go would be one of these, which would be chromium 2 plus, and then there's one more bit we have to do because we've not been asked to make chromium 2 plus, we've been asked to make chromium 3 plus, okay? I'm just going to bin all this off now because it's going to go on the actual line, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s is completely gone, 3d, 3, okay? There's the answer. Next question. Deduce the formula of the ion that has a charge of 2 plus with the same electron configuration of krypton as krypton. Back to periodic table. So, the action here is focused on krypton, and what it's saying is find something that's got the same electron configuration as that. So the way the periodic table works is things nearby to krypton will adopt its electron configuration, and that works to the left here, but it also works to the right here on the next row down, on the next period down. All right. So what it's basically saying is which one of these things is going to adopt krypton's electron configuration by losing 2 electrons. And again, this is very kind of basic stuff in the sense that you should know that these elements, selenium and bromine, the ones on the left of it, those two are going to gain electrons to form a kind of, noble gas configuration. These metallic elements down here, the group 1 and group 2, rubidium and strontium, they're the ones that are going to lose the electrons. So, given that we've already done the legwork here, we know that strontium forms ions with a charge of 2 plus because it's a group 2 element. That's what we've been asked about. It must be strontium. Just have to take care because it asks for the formula of the ion, which means we're not just going to put SR because that's the formula, symbol for the element. It must be SR2+. That's what we've got to give as our answer. Next question. Deduce the formula of the compound that contains 2+ and 3- ions that both have the same electron configuration as argon. This is a similar sort of question. So it's asking us to center our attention on a noble gas, right? I'm just going to see if I can get rid of some of this stuff. There we go, that'll do. All right. So this time the noble gas is not krypton, it's argon. Okay. It's the same sort of idea, right? We're going to be looking at elements that are nearby to argon. Okay. We're looking for 2+ ions and 3+ ions this time because it's going to be a compound that we have to construct. So the 2+ ion, it's the same kind of thing. It's going to be the group 2 element, so it's going to be calcium, right? The 3- ion, this time we're having to look backwards. Because we've already marked off this, then we know it must be phosphorus, which means we've got our 2 ions already. We've got Ca2+ and P3-. That's still not the answer though, because it asks for the formula of the compound that contains these things. So this is another kind of generic, early on A-level chemistry skill that is also kind of expected at GCSE. We have to figure out how to make these, how to make these into a neutral compound. There's a thing called the crossover technique or swap and drop or whatever. You can do that if you want. I personally prefer to explain it because if you were ever asked to justify this in words, then you should be able to really. You need 3 calcium ions to achieve a charge of +6. you need 2 phosphide ions to achieve a charge of -6. It has to be 6. 6 is a special number because the lowest number that both 2 and 3 go into is 6. That means that you then multiply out to Ca3P2. And yes, that's the same answer that you would get if you did the kind of cheaty method of going 3 minus, 2 plus, right? But the reason I would discourage that, same as I do at GCSE, is because I think it's better to be able to explain it, because you never know when there's going to be a question that's 2 or 3 marks worth that asks why calcium phosphide has a formula of Ca3P2, and you might get a mark for saying that it's got Ca2 plus and P3 minus, but you're not going to get a mark for saying, well, I swapped and dropped them. So, think about it that way. So, next question.